Good afternoon, everyone. Hope all of you have a better understanding of how to leverage on Yugabyte CDC to build your data engineering pipeline from the previous session. So for my session, we will deep dive more from the architecture perspective. So in database history, MySQL is one of the most successful open source database that is still widely adopted by the industry. So let's review how MySQL was built to deliver its HA architecture, then compare it to the modern capabilities of distributed SQL and how new databases like Yugabyte can improve the ability to deliver HA for today's cloud-native applications. Just a little bit about myself. My name is Ron. I'm the Senior PCO Solution Specialist in Yugabyte. So before joining Yugabyte, I was doing all data products. So I was handling relational databases in Visa, then doing data warehouses and in-memory data grid in Pivotal Times. Then right before joining Yugabyte, I was in HP Admiral, where I was handling data platforms, AI, machine learning, and Kubernetes. So in case you guys have any questions, feel free to discuss after the session. So to start with, let's just quickly recap the MySQL history. So in the early 1990s, just as the World Wide Web was being introduced to the world, a network monitoring service named Nirvana was created, an affordable version of a MySQL called MySQL. And it was not open source, but eventually it was still free for non-commercial use. And a few years later, three person, Alan Larson, David X. Mark, and Michael V. Daniels, three of them adopted the MySQL into a more robust interface. So they named it MySQL. And it actually named after V. Daniels' daughter, MY. So in 2005, Oracle actually purchased the Innobase, which is a company that managed MySQL's Innobase storage backend. So the storage engine later on built on top of it, which is InnoDB, allows the MySQL to have important functions such as supporting of transactions, foreign keys, ISIC compliant, etc. So when Sun Microsystems bought MySQL in 2008, the community became suspicious of the new owner, and different fork versions of MySQL came into picture. So V. Daniels left MySQL shortly after the buyout, and he made very public criticism of Sun and Oracle as acting the contrary to the spirit of open source. So they began a new campaign called the Save MySQL campaign. So when Oracle just bought Sun shortly afterwards, for V. Daniel, that moment actually marked the birth of the MariaDB. So the name Maria is one of his daughter as well. And the MariaDB is an open source alternative to MySQL. And you can treat it as an improved or enhanced version of MySQL. It offers additional capabilities like a columnar storage format, parallel, querying, rewrite splitting, point-in-time rollback, dynamic data masking, etc. Right, so this is one of the MySQL forks. And another one, another famous MySQL fork is actually Percona. So Peter and Vadim introduced the open source Percona in 2006. So two of them has spent a great deal of time supporting MySQL and saw that what business really wanted from MySQL. So they incorporate those aspects and made it more affordable. So there are two, if you want to find the difference between the Percona server for MySQL and the Oracle MySQL, you can easily find it on Percona's official website. But there are two interesting facts I want to share over here. One is that Percona MySQL supports the MyRocks as the storage engine. So MyRocks is a MySQL storage engine based on RocksDB. So it's an embedded persistent key value store. So for those who are not familiar with RocksDB, it's just a storage engine leverage on the LSM tree implementation. So compared to the B tree, LSM tree has a data structure that is catered more to the modern hardware, has a better compression ratio, easier to implement, etc. So the MyRocks actually is a great addition to MySQL for the modern hardwares and the cloud infrastructures. And the second interesting point is XtraDB cluster. So Pocona integrates the proxy SQL as a routing layer and use Galera to achieve the high availability of the storage nodes in the clustered architecture. But however, like MariaDB, the most suitable use cases for XtraDB cluster are vertical sharding of tables and databases. So it's not a real distributed database that supports the horizontal scaling. All right. So we have seen the evolution of MySQL and a few Fox version of MySQL. Now let's take a look like how MySQL incorporates its HA architectures. So natively, MySQL supports the asynchronous replication. Normally, we call it master-slave or leader-follower kind of replication setup. So the master node will process the transactions, then those transactions will generate binary logs, then the logs will be shifted into the follower side, then translated into a relay log, then replay on the slave side. Okay, so this is an architecture that is widely adopted in the MySQL community, right? And to some extent, it can help you to offload some of your rate requests. However, it is still a single node for all the writes, and the replication is asynchronous, and there will be a lot of operational overhead in terms of failover when you want to do upgrades, when you want to do maintenance work. So you still need to manually configure all the stuff, right? And there's a variation to the native replication. So by default, the native replication is asynchronous. However, you can change it to semi-synchronous, meaning that the slave side will confirm the reception of the message or transaction before the master node send the success message to the client, right? But the drawbacks are still remain the same. Gorilla, it's another code shapes of vanilla version. So no matter it's a MariaDB cluster or Pocona XtraDB cluster, they all use Galera. So they also use the InnoDB storage engine under the hood, and it supports the synchronous multi-master setup and auto failover. But there are a couple of things you need to take note. So for example, it doesn't really it's not very good to handle large transactions or DDLs. And even though the replication is synchronous, however, the applying of those records is asynchronous. So when you are reading the same records simultaneously from all three nodes, it still may there will be a slightly lag over there, right? And oftentimes, because of the drawbacks of this kind of architecture, people will still default back to the single master mode instead of having a multi-master. Another HA architecture that is developed by Oracle MySQL itself is actually the group application, or we also call it InnoDB cluster. So on top of the group application cluster, they also invented other two components like MySQL shell to manage, to orchestrate all the cluster operations, and also a lightweight middleware component called MySQL router to be embedded together with a app server, so that it will help the application to route the traffic to the master node, or in the event of failover, the router will know which is the next master node, right? And in the communication protocol, it actually for group application, it uses XCOM, which is very similar to the Paxos. So it requires majority to acknowledge. So in contrast, for Galera, it requires all the nodes to acknowledge. And for MySQL group application, it also does the auto failover. But some of the drawbacks are it doesn't offers the automatic provisioning. For example, for the 3-node cluster, if you want to add in another node, another 1 or 2 nodes, etc. So there's a lot of manual work you need to do, not an automatic setup. And when another important drawback is that when the network partition happens, the partition node will only will also continue to accept the reads and the writes. However, the writes will hang forever and needs to be manually rejoin the cluster. So not sure whether it is a bug or a limitation for the current setup. And also, it's not feasible to do the data distribution across geographic locations, right? Just to summarize, these are the things that in common for different MySQL high availability designs. So no matter it's native or Galera or MySQL group application, all those things are shared nothing architecture, meaning that each node will have a complete copy of all the data, right? And some of the architectures support multi-master, but it's not mature. So oftentimes people will still default back to the single master mode. And from the scalability perspective, it only supports vertical scaling. So you cannot do horizontal scaling. And in terms of the management or operation perspective, there were extra or additional components that you need to manage. For example, the MySQL router, MySQL shell, or things like that, right? So are there better ways for us to handle the high availability design? The answer is yes. So from 2015 onwards, there's a new type of database came into picture called distributed SQL databases. So they have a layered architecture and distributed in a fashion that you can still logically treat it as a single database, but it has a cluster setup and data is automatically distributed across all the nodes in the cluster. So it still have a SQL API layer, which is interacting with your application. And the SQL will come into the distributed query execution layer. Then it will fetch the data from the distributed storage layer. So the storage layer also will take care of the data replication across all the nodes in the cluster, and also at the same time maintain the distributed asset transactions, right? So Yugabyte is one of the example for the distributed SQL in a sense, and it has a 2-layer architecture. So on the top is a pluggable query layer. So on the bottom is a distributed transactional storage layer. So we're not here to invent another database for people to use, but rather than a data platform, depends on the workload, right? So right now we offer 2 APIs. One is Postgres compatible API. The other one is Cassandra compatible API. So depends on the workload nature, you can choose either of the two. And we have other APIs coming in the future as well, right? So on the bottom is a distributed transaction storage layer. So this layer actually does all the magic things. For example, automatic sharding, load balancing, distributed transactions. Then the data replication is done through the rough consensus algorithm. So all these things are handled by the database layer. You don't need to configure other components like MySQL router, things like that. And at the same time, when the data is written into the YugabyteDB, the data is automatically sharded and distributed across all the nodes in the cluster, so that when you're adding the extra node into the cluster, you can leverage on the automatic provisioning and the data reshuffling or data migration is all happen automatically and on the storage layer. So you don't need to worry about how do I reshuffle the data, how do I redirect the request to the new nodes, etc. All those things are automatically handled by the YugabyteDB itself. Right. Then in terms of the underlying infrastructure, we are actually infrastructure agnostic. So we support the deployment on AWS, on GCP, on Azure, even on different flavors of Kubernetes, or even on prime data centers. So we don't want to lock any locking on the infrastructure, but it's just you are free to choose your own infrastructure to run YugabyteDB. Right. So here I list down a quick architecture difference between the single node architecture like MySQL and a cluster architecture like YugabyteDB. So for MySQL, is fairly straightforward. The client connect to the query layer connect to the storage layer, then fetch the data like from the disk, etc. But for the YugabyteDB, it's a cluster setup, so the data is actually distributed across all the nodes, as you can see here, for different tablets. So we're actually doing the partitioning on the original table. So it will partition it by different into different tablets, and a tablet is just a group of rows in the table itself. And you can see that by default, for each piece of data, we'll have 3 copies. As you can see here, tablet 1 has 3 copies, tablet 2, tablet 3, and tablet 4. So in case of the node failure or whatsoever, like maintenance jobs or upgrades, as long as there were majority copies that are available, then the data will be still available to your applications. So there won't be any downtime from the application perspective. So whenever it's a unplanned failure or planned maintenance, you can always have a 0 downtime throughout the operations, right? And this is a high-level comparison between the different HA architecture in MySQL and YugabyteDB. So in terms of scalability, the 3 HA architecture offer MySQL, no matter it's a native replication, Galera cluster, or InnoDB cluster, all of them is vertical scaling, meaning that you can change a smaller machine with a large machine, pumping in more CPU and memories, right? But at some point, the performance will still saturate no matter how much CPU and memory you are pumping in, right? So for YugabyteDB, we support both vertical or horizontal scaling. So you can change the database node to a larger node, similar like the other MySQL HA architectures, or you can also add in another node to scale horizontally, right? Then in terms of multi-master support, so for native MySQL, it doesn't support multi-master because there will be replication conflicts over there. Then in terms of Galera or InnoDB cluster, is very limited. And because of those limitations, people will still prefer to default back to the single master node, single master architecture. Then for Yugabyte, by default, we are a multi-master cluster setup. So every node is a read and write node. So you can point in your application to any of the nodes or at the same time, right? And in terms of capacity, it is actually the limitation of traditional single node architecture databases. Normally the capacity is around 1 or 2 terabyte. That's a maximum capacity that the single node can hold. And also because of the scalability is only vertical, right? It's a shared nothing architecture. Every node has a full complete copy of the data. So one node can only have maybe 1 or 2 terabyte, meaning that even if it's a MySQL InnoDB cluster, the maximum size they can have is also 1 or 2 terabyte, right? But on the other side, YugabyteDB supports the horizontal scalability. So you can scale it, like you can have a cluster with hundreds of nodes. So you can easily scale out to hundreds of terabytes, right? Then in terms of failover, both Gorilla cluster, InnoDB cluster, as well as YugabyteDB supports auto failover. Then for the native MySQL replication, by default, it's manual, but you can use other third-party tools or load balancers, etc., to build on top to kind of make it automatic, but there will be extra work you need to do, right? And in terms of operational overhead, of course, for the native replication, the operational overhead is very high. Like you want to, in terms of a failover, first you need to stop the application, you need to stop the replication, then you need to point the application to the slave side, then reset up the replication, etc. All these work need to be done manually. Of course, you can automate those as well, but it still will be operational overhead, right? So for Gorilla cluster or InnoDB cluster, it kind of automate quite a number of stuff. But in terms of, for example, you want to add in another node, you want to remove a node from the cluster, things like that. It's still there's no automatic provisioning over there, so you still need to do it manually. But for us, for YugabyteDB, if you add in another node into the cluster, right? So the configuration of the cluster, the reshuffling of the data, load balancing, all this will be done automatically by the cluster itself. So there's no manual intervention that is required. Lastly, I want to talk about the different flavors that we offer as part of the YugabyteDB. So we have 3 consumption models that are supported at the moment. So we are 100% open source. So you can even find our source code on the GitHub over here. So you can download the free community version and try out on your own. And it is infrastructure agnostic, as I mentioned, right? And we also have 2 other enterprise versions as well. One is a fully managed version, right? So from infra all the way to DB will be managed by us. The other is a self-managed DBus version. So we'll help you to set up a management portal to help you guys do with all the database operations, deployment, management, all the data operations, backup, etc. So no matter which version you are using, for the core DB functionalities, they are the same, right? Like distributed load balancing, the data sharding, data replication, all those things are inbuilt in the DB itself. And it's the same, no matter you are using community version or the enterprise version, right? I think that's all I want to share today. And we also have our own community Slack and GitHub. In case you have any questions, feel free to post it in the chat. Happy to answer those. Thank you.